Hey everyone, it's Jackson. I'm here today with my friend and colleague, Jim Abbott, the Director of Operations for North America from the A.G.I. Group. We're here today to talk about our hybrid filter reactors, some of the key features and benefits, and commonly asked questions about this equipment. Jim, thanks for joining me.
Thanks for having me. It's wonderful to be out here in Portland.
Very grateful that you could join me today to, go over some of these questions that a lot of people have when they're looking at a reactor. The first and biggest question is, what makes this a hybrid? Why is it unique? What makes it stand apart from different reactors that people might be looking at in this industry?
It's a good question. The hybrid reactor was actually a collaboration between AGI and Cascade Sciences. They merged the benefits of a NUSH filter system and a filter reactor into a hybridization system that incorporates the best of both worlds into a unique design with unique features that allow users to have much more targeted application driven results in their process.
That's great that you're using key features from both a NUSH and a filter reactor. One thing that I've noticed with the hybrid filter reactor versus a NUSH that I've worked with before is instead of a hand crank for the impeller, there's a motorized overhead stir. Can you kind of speak to me about what the benefit is and the reasoning behind that addition?
So we went with an agitated stir that is unique to the filter reactors in the systems versus the hand cranking of the AGI NUSH filters. Mm-hmm. This was because most people in the processing were trying to do crystallizations and they needed some type of agitation. But they also wanted to have a drying or a feature for the vacuum filtrations where they could actually reduce down to a cake in the system and then be able to actually dry it out so that they can, before they actually are starting to go to their next process. Mm-hmm. So we looked at these benefits and then decided that, well, the raising and lowering mechanism is quite a benefit in order to do this. And utilizing the same blade style as a NUSH filter really was allowed us that cutting, that mixing that we needed, and the smoothing of the cake to get the really high drying content out of there that in the process. So it was something that we decided to explore a little bit further, and that is why we decided to go with the development of this hybridization on the top to allow us the mobility.
I like that. The mobility is a really thoughtful design. I think that not only in addition to helping and assisting with drying, the ability to move that impeller blade up and away from the cake really probably adds and assists in the ability for the isolate removal. Because I've noticed a few different things with the hybrid filter reactor that I've seen in other similarly marketed filter reactors. The first one being the filter plate size. I noticed that on the 20 and the 50 liter filter reactors, the filter plate is the entire OD of the vessel. On other ones that I've seen, it kind of funnels down and seemingly has kind of a one size fits all type of filter plate. Can you kind of speak to that a little bit?
For the filtration process, as we decided when we were developing this, that we knew that the NUSH filters had the large filter bases, and so do the filter reactors in general, but that surface area was wide enough that we could build up a lot of material and have a greater area for drying and also cake removal, speeds up the processes and different things like that. Mm-hmm. So it was really a benefit to us. Instead of having like a one size fits all, we really wanted to maximize it. So we maximized that filter diameter, got it as big as we could, made the glass quite large. One of the unique designs, I don't know if you noticed, is that our jackets of our reactors go all the way to the base of the filter so that there's no dead spots in heating and cooling, that the entire area is heated and cooled, which does lend to maximize the efficiency of the heat transfer, but also the drying of the process.
I love that feature about it. That's something that you definitely don't see in other reactors, and not having that dead space is going to be really, really helpful in repeatability, understanding, so that temperature consistency throughout the vessel is really going to be very, very helpful. Really seems like AGI and Cascade Sciences have taken a lot of careful thought into the removal of the isolate. I really love the mobile cart. Can you kind of speak to why that is a great idea, how that's going to benefit change over time, mobility, things like that?
So moving the cart and is an integral part and feature of the system. That way you can change out and for efficiency. When we were looking at doing this, one of the thoughts was that this is going to be used in an industrial process where people aren't going to want downtime. They're going to want the ability to put another filter in the process. But in the same utilization of that, we said, well, we want to make sure that we have minimal product contact with the users. We don't want minimal product contact with anybody that's in there. So we wanted to make sure that you can unhook the filter system from the glassware and lower that out of the way without having the ability to come in product contact. So it's really a good manufacturing process that we looked at as we were developing this, and that's really the driving factor of this. This is a similar thing that we do with our smaller filter reactors, which mimic the larger scale systems. Mm-hmm. We do the same thing. We hand crank the filter bases down. That way that you're isolated, or you're not. And you're not completely isolated, but you're away from the product and you're not having the direct product contact.
I really like that idea of mitigating touching of the product. Another thoughtful idea that AGI and Cascade came up with the hybrid filter reactor is the overall frame design and how the vessel sits relative to the cart. On some of those larger models, I know it's at least 16 plus inches of clearance from the bottom of the vessel to the top of the filter plate. So I really think that that's going to help from an industrial standpoint in terms of throughput, minimal contact, ease of transfer, all of these things. Do you agree?
Oh, I agree 100%. That was the idea and the thought behind this. Maximizing the surface area of the filter, maximizing the amount of distance that we have of the heating material, so being fully jacketed all the way up, that really does lend itself to build larger, deeper cakes into the system, especially with the ability to raise the agitator out of the way. Mm-hmm. You can bring that above there, and you can build more filtered media and everything like that. And yeah, you're definitely correct. You're going to mitigate that product contact, or even which easily says if you don't have product contact, you have less of a possibility for getting any intrusions into your things, or any anomalies that are going to occur in your process.
Well, Jim, thanks again for flying all the way out here from New Jersey to Oregon to come talk with me about the hybrid filter reactors. Really appreciated your insights on what makes it unique and all of the really fun features that make this product something that we're really proud of, and I know the AGI group's really proud of. So once again, thanks a bunch.
Very much appreciated, and thank you for having me out here at your wonderful facility, and I'm looking forward to working with you for a very long time.
Thanks again, Jim.